Hi everyone, I hope you're okay, and I really hope that guys the videos will keep uploading are helping you out. This is video number 7, which simply means I'm doing question 7, guys. Please expect a total of 33 questions. Organic chemistry is a big chapter, guys. It is separated it is divided rather into 3 parts. Uh, which simply means the first section has 11 questions. The second section has 11 questions as well, and then your third section has 11 questions. In total, you'll find 33 questions. Just stay tuned, guys, and yeah, I hope you'll learn a lot. Okay, question 7. We are told that letters A to E in the table below represent 6 organic compounds. Before we even start, guys, you know the vibes. I just need to go and analyze each compound individually. Uh, so whenever I'm given a structural formula, I must go and write the IUPAC name. If I'm given the IUPAC name, I must go and draw the structural formula. Okay, before I even answer the questions, let me go to compound A. Compound A, I'm dealing with an alcohol. How do I know it's an alcohol? Because I have the hydroxyl group are together. So what kind of an alcohol is this one? This is a tertiary alcohol. Why? Because the carbon which has the hydroxyl group is bonded to 3 other carbons. 1, 2, and 3 are together. So I'm dealing with a tertiary alcohol. Okay, let's name this tertiary alcohol. I must start counting closer from the terminal carbon, which is closer to the functional group. So when I start from left to right, I will be closer to my functional group. Ne? This will be 1, 2, 3, and 4. So this is my parent chain. In carbon number 2, I have a side chain, or rather an alkyl group, and also the functional group. So whenever I name this organic compound, I need to start by mentioning the alkyl group. So this will be 2-methyl butane 2-ol. Are we together? Okay, then compound B. Compound B is an aldehyde. How do I know it's an aldehyde? Because the double bond O is at the terminal carbon, and this functional group, it's called a formyl group. Ne? It's easy, guys, to name aldehyde. This will be just a butanal, the IUPAC name. Compound C, I'm given an IUPAC name. All I have to do is to draw a structural formula. Ne? This has 4 carbons. 1, 2, 3, 4. It's so simple to draw structural formulas. The alcohol is in carbon number 1, so I'm dealing with the primary alcohol. Why? Because the OH is at the terminal carbon. So that's the structure of butane 1-ol. And then compound D, I'm also given an IUPAC name. All I need to do is to draw a structural formula. It's butane 2-ol. I'm dealing with the ketone. Why? How do I know that this is a ketone? Because of the suffix of this this compound. And I'm told that in carbon number 2 I have my functional group. So the structure will just be like this, and then the functional group will be in carbon number 2. Okay, and then let's go to compound D. Compound D, I'm dealing with an alcohol. How do I know this is an alcohol? Because I have a hydroxide or a hydroxide ion bonded to a carbon. Yeah? And whenever I name an alcohol, guys, I need to start numbering the carbons from the terminal carbon, which is closer to the functional group. And what type of an alcohol is this one? It's a secondary alcohol. It's secondary because the carbon which is bonded with with the functional group is bonded to other two carbons. Are you together? This one is a primary alcohol because the carbon bonded with the functional group is only bonded with one carbon. Compound A was a tertiary alcohol because the carbon bonded with the functional group is bonded with three other carbons. So we are dealing with the secondary alcohol in compound E. Our longest chain, guys, should have the carbon with the functional group. So this will be our longest chain. I will simply have carbon number 1, 2, 3, 4, 5, 6, 7, and 8. So my parent chain has 8 carbons. Are you together? But I'm realizing that I have side chains. Excuse me. In carbon number 6, there is a side chain. In carbon number 5, there is another side chain. These two side chains are different. This one, since it has only one carbon, it's called methyl. The one that has two carbons is called ethyl. Are you together? Whenever I mention these side chains, I need to mention them alphabetically. That means I'll start by mentioning ethyl because alphabetically ethyl should come first. Are you together? And then followed by methyl, and then deal with the actual compound. So the IUPAC name for this thing, I'll simply say in carbon number 5 I have an ethyl, and then in carbon number 6 I have methyl. And then since the parent chain has 8 carbons, so the prefix will be octane. The hydroxide ion is in carbon number 3. It's octane 3 all. So that would be the IUPAC name of compound A. Okay, so let's answer the questions. Let's write down the letters that represents each of the following. A tertiary alcohol. Remember that I said a tertiary alcohol is compound A because the carbon bonded with the OH is bonded to other 3 carbons. An aldehyde, that's compound B because it has a formal group. Ketone, that's compound D. The suffix told us. Are we together? Okay, a functional isomer of compound B. A functional isomer of an aldehyde will always be a ketone. Are we together? But remember that, guys, functional isomers are compounds that have the same molecular formula, and they have different structural formula, and obviously they belong in they have different functional groups as well. So the isomer of compound B will be compound D because ketones and aldehydes are always isomers of each other. So you will write D again there. The IUPAC name of compound B, it's just butanol. And then the IUPAC name of compound E, we said it's 5-ethyl, and then 6-methyl. Please do not mix letters and numbers. Ne? Always separate them using a hyphen. Methyl, and then this is octane 3 all. Okay, define the term positional isomer. A positional isomer is just a compounds that have the same molecular formula and have functional group located in different positions. And then write down the structural formula of a positional isomer of compound C. Compound C is butane 1 all. It simply means that the OH ion is bonded is rather at the terminal carbon. So the functional isomer of compound C, I'll just move the OH to a different carbon. I'll simply have it like this. I'll have my hydrogens over there. and then I'll have my OH on a different carbon. So this is a positional isomer, right? The molecular formula is the same, functional group is the same, but molecular formula is the same, homologous series is the same, functional group is the same. It's just that the functional group is in different position. So the IUPAC name of this thing will be butane 2-ol. Did they want the structure? Okay, the structure will be that one, ne? The structure will be that one. Let me just draw it here. Butane 2-ol. Remember that this over here, let me write it with a different color so that you will see that it's different from the others. Okay, I must write down the structural formula of compound D. What is compound D? Compound D is a ketone. I've already drawn the structure there, ne? But let me just draw it for you here. Butane 2-ol. I'm dealing with a ketone that has 4 carbons. I'm just lazy to write the hydrogens, ne? But let me write them, guys, because you will forget as well, and then you'll get wrong answers. That's butane 2-ol. And then now we must write the structural formula of the organic acid that will react with compound C to form butyl propanoate. Okay, butyl propanoate is an ester, ne? The butyl part comes from an alcohol. That means they've used the primary alcohol, which was butane 1-ol. Are you together? And then the propane should come from a propanoic acid. Are you together? If you mix the two, you will form an ester, and the name of that ester will be butyl propanoate. So the structural formula of this organic acid is just propanoic acid, ne? You will have your H's over there. That's propyl, that's propanoic acid. Are you together? We will use propanoic acid to form our ester. That's how, guys, you could have tackled these questions. I hope, guys, the videos really helped you. Thank you for your time.